So the topic that I chose to present on was Bartolomeo Eustachio and how he described the brain origin of the optic nerves. Some background information on Bartolomeo is that he was an Italian anatomist from San Severino, and he was the son of Mariano Eustachio, who was a successful physician from a noble family. Mariano insisted on his son receiving a well-rounded and humanistic education, which led to Bartolomeo being proficient in Greek, Hebrew, and Arabic. And then eventually Bartolomeo went on to study medicine in Rome and returned home to practice. And then soon after that, around 1549, Bartolomeo began teaching anatomy and researching, which is when one of his most notable discoveries came about. So I found an article called The History of the Optic Chiasm from Antiquity to the 20th Century, and the article just aimed to thoroughly explain the history of the optic nerve and the optic chiasm by looking at and explaining the works of ancient, medieval, and Renaissance neuroscientists, particularly Bartolomeo Eustachio. And he's known as the first neuroscientist to establish an accurate description of the path of the optic nerves, and he was also able to identify the optic chiasm. He claimed that the optic chiasm was part of the path of the optic nerve and that it did not extend to the lateral ventricles, as the ancient Greeks had previously argued. And he also believed that the chiasm did not extend directly to the brain, but that it first proceeded through the posterior portion of the thalamus. And although these discoveries were made around 1550, shortly after he began researching, they were ignored and kind of forgotten about in the Vatican Library until 1714 when they received attention from Pope Clement XI. So although much research had to be done after Bartolomeo's discoveries, they helped us to get where we are today with knowledge of the optic nerve and chiasm. And now we know that the optic nerve, also known as the second cranial nerve, is one of two that do not join with the brainstem. And the nerve develops from the optic vessel in the embryonic forebrain, which indicates that the entire nerve could be considered as a part of the central nervous system. We also know that it's what connects the eye to the brain, and that the function of the nerve is to send visual information via impulses to the brain, and these impulses are formed by the retina, which is the nerve layer that lines the back of the eye. The point of intersection of the optic nerves from each eye is known as the optic chiasm, and it's an essential X-shaped structure, and it allows for binocular vision. And that's just simply explained by vision using two eyes with overlapping fields of view, which subsequently allow for good depth perception. And more specifically, the anatomical pathway of the optic nerve can be then described extracranially or intracranially. Extracranially, the optic nerve is formed by axon of the retinal ganglion cells, which receive impulses from photoreceptors, and the nerve then leaves the orbit through the optic canal and enters the cranial cavity. And then intracranially, the nerves will come together and form the chiasm and the optic tracts, which can be seen in the image on the right. And the left optic tract is composed of fibers from the left temporal retina and the right medial retina. And then the right optic tract is then composed of fibers from the right temporal retina and the left medial retina. Each optic tract then proceeds to the cerebral hemispheres and reaches the lateral geniculate nucleus in the thalamus, and that's kind of similar to what Eustachio declared in 1550 when he first began researching.